Now say series combination of resistors. For example, you can take three resistors are connected in series. This is a cell. The potential difference across the cell is V. Resistance R1, R2, R3. Some current is flowing through the circuit. That you take it as current I is flowing. So here only one loop is there, so only one branch. So in a given branch, if all the three resistors are connected in series, then current is same for all the cases. Through the cell, current flowing is I, and through R1, R2, R3 also current flowing is I only. And this potential will be divided into three parts across first resistor V1, here V2, V3. What you can write, the potential, total potential across the cell is equal to potential across first resistor plus potential across second resistor plus potential across third resistor. In series combination, current in every device is same but potential divided. So here according to Ohm's law, what you can write, V1 is equal to, we can write current is I and resistance is R1. And what is V2? Current is I and resistance is R2. And for third resistance, current I same only but resistance R3. This also we can write as total current flowing is same as I and resistance, that only what we call series resistance, series combination of the resistance. This is a total current into total resistance. Across first resistance, across second, across third resistance. From this, what do you get? R series equal to R1 plus R2 plus R3, like this we get series combination. So series combination, current is same, current is constant, I is constant. And what about potential ratio? V1 is to, V2 is to, V3. Three resistors are there, means potential divided into three parts. Then how it depend upon? It depend upon resistance value. Which is having more resistance, that has more potential. So I is constant. More resistance, more potential. So you can write R1 is to, R2 is to, R3 you can take. In series combination, potential divided, current is constant. In series combination, resistance, sum of all the resistance we can take. Suppose you can take this type of resistors, n identical resistors are there, each of resistance, like that n resistors are there, each of resistance R, all are connected in series. What is the total resistance now? R plus R plus R, like that you can add according to this formula. Then R series equal to, how many they add like this? Like this they add n resistors. So total resistance is R into n, NR we get. Suppose only two resistors are there. Resistance R1 and R2. Potential across them is V1 and V2. Of course current is same. Suppose if you connect a battery here, and battery potential is V, and what is the current set inside? Current is equal to, here we can write current I is equal to total potential by total resistance, R1 plus R2. What about potential across first resistor, V1? V1 is equal to, we can write according to Ohm's law, IR, I nothing but this only. So we can write V R1 by R1 plus R2, potential across first resistor. Now potential across second resistor, V2 is equal to, here total current is this into R2, potential across second resistor V2 is equal to IR2, that is V R2 by R1 plus R2. So how potential is divided in series combination means, total potential into across which resistance we are calculating, that is faster. So that's why R1, that resistance, by total resistance we can do. Similarly here, if you want in 3 resistors are there in series, then what you get potential across suppose first resistance you can take V1. How to write? How to write V1 in this case? According to that, V1 is equal to total potential V into across which resistance we are doing, first resistance. So that resistance R1 by total resistance R1 plus R2 plus R3 we can write. Okay, in series combination current is constant and potential divided. How potential divided? According to ratio of their resistance, directly proportional to R. So we can use here V is proportional to R. We get relations like this, potential ratio. Now let's see parallel combination of resistors. Suppose you can take a EMF, or you can say a cell which is having potential difference V across the terminals. One is positive terminal, other is negative terminal, and 3 resistors are connected like this. R1, R2, R3. Some current is flowing from positive to negative. So current flowing is I. That current will be split into 3 currents, that is I1, I2, I3. These 3 add up here. Again it flows as total current I. So here how much current it flows here, same current enters here. This is a parallel combination. So one of first end of all the resistors connected at one point, other ends are connected at other point. This is a parallel combination. In parallel combination, whatever the potential here applied across the battery, that is same for each and every resistance. But because you see across R1 is connected across the cell, R2 also connected across the cell, R3 also connected across the cell. These are good conducting wires. So we can take here potential across R1 is V, across R2 also V, across R3 also V, across cell also V. Why? Because all 4 are parallel here. So in parallel combination, potential is same. What about current? Here the current enter here will be split into 3 parts. I1 plus, I2 plus, I3. According to Ohm's law, what you can write? Current I. Current I we can write as potential by resistance. So what is a potential by resistance? First we write like this. Current. First we write about I1. I1 is, what is potential across first resistor? That is V. V by R1. That is I1. V by R1. For second V by R2. V by R2. Here potential is common. Current is different. So calculate current. Potential by resistance. What about total current? Total potential, that also potential across the cell, that is same as V only. All are having same potential. By total resistance we don't know, that only you have to calculate, that are parallel. So here what you get, 1 by R parallel is equal to the resultant resistance, 1 by R parallel is equal to 1 by R1 plus, 1 by R2 plus, 1 by R3 we can write. So parallel combination of resistance, how we are getting, that is here 1 by R1 plus, 1 by R2 plus, 1 by R3 we get. Suppose here how current is divided. So how current divided? Here ratio of currents, we can write like this. The current in parallel combination, I1 is 2, I2 is 2, I3 is equal to 1 by R1 is 2. 1 by R2 is 2, 1 by R3, because potential is constant. So resistance, current is inversely proportional to resistance. More resistance, less current is flowing through that branch. Here if you take 2 resistors in parallel, only 2 resistors are there. R1 and other resistance R2 are connected in parallel with a cell EMF. And here we know current flowing is I1, here current flowing is I2. The main current is I. In series combination, potential divided, here current divided. How current is divided? So first of all, here current I1 is equal to, we can take total current into R2 by R1 plus R2. So how, in parallel combination, how current divided? So total current into other resistance. Suppose if you want current flowing through R1 and we need I into R2 by total resistance. Similarly, what is current flowing through second resistance? I2 is equal to total current into R1 by R1 plus R2. There, in case of series combination, how potential divided? And total potential to same resistance. Here, other resistance, because inversely proportional. There, directly proportional. Suppose like this, n number of resistors. N number of resistors are connected in parallel. All are identical resistors. Suppose you can take here n number of resistors. Like that, n number of resistors are connected, each of resistance value R, or like that n number are connected in parallel. Then what is the resistance between these 2 points? That is R parallel is equal to R. 1 by R parallel is equal to, what is formula? 1 by R parallel is equal to 1 by R plus 1 by R plus 1 by R, like that. How many times you have to write? N times. So what do you get? N by R we get. So R parallel, from that what do you get? R by N we get. If n identical resistors are connected in parallel, what happened? Resistance become R by N. Same thing in series, what happened? It become n times of R. So if you want more resistance, you should connect resistors in series. If you want to decrease the resistance, you should connect resistors in parallel. So in series combination, what you get? R1 plus R2 plus R3 plus, like that. So in series combination, what you get? Resistance more than bigger value in the given, more than the bigger value of the resistors. And parallel combination, less than smaller value you get. Suppose for example, we can take example 2 ohms, 5 ohms and 7 ohms is there. If you connect in series, what you get? 2 plus 5 plus 7, you get more than 7, a bigger value. Suppose if you connect in parallel 1 by 2 plus 1 by 5 plus 1 by 7, after solving and take reciprocal, that you get less than 2. So in series combination, you get more than bigger value, and in parallel combination, less than smaller value we get. Combination of resistance. Example 1. There. Between A and B, what is the resistance? If they give all these values is 5 ohms, 10 ohms, 5 ohms, 10, 5, 10, 5 if they give like this. All are in series. So resistance between A and B, RAB is equal to 5 plus 10 plus 5 plus 10 plus 5 plus 10. Like that we can do 30 plus 20. Then we can write 50 ohms total. All are in series. Suppose if they give 3 resistors, R1, or otherwise you can take 15 ohms, 15 and 10 ohms. Then what is the resistance between A and B? RAB, direct question. It is all our series. So 15 plus 15 plus 15, 45 ohms you get. The same question if they give that like this, same question. Point A, B, 15 ohms, 15, 15. They connect a wire, a good conducting wire like this. That's what we call short circuit. In that case, what is the resistance between A and B? That we get 0. But because there is a good conducting wire, current flows through this wire, it won't use this path because that high resistance is there. So this is a short circuit, then there is no resistance between these 2 points. Same case if they give like this, A, B, that is 15 ohms, this is A, and this is B, and if you connect a wire like this, in this case what happened, these two are short circuit, these two resistors are short circuit, and this is not short circuit. So you can take this point A, this point also A. Why? Because directly connected here. Between A and B, 15 ohms is there. So here RAB is equal to 15 ohms we get. In this, another case also there. A, B, 15 ohms, 15 ohms and 15 ohms. A wire is connected like this, other wire is connected like this. In this case, what you get resultant resistance between A and B. For this, you have to modify the circuit. How we are getting, you see, at point A. First resistor, one end connected at A. What about other end? Other end indirectly connected to B. Why? Because this is a short circuit wire, it is connected to B. Now about second resistor, one end, you see, one end connected to A, short circuit wire, and other end connected to B. So one resistor also, one end connected to A, other end connected to B. This second one. Third one end connected to, suppose this is the third resistance. One end connected to B, and other end connected to A. Connected to A. So all three are 15 ohms, 15 ohms and 15 ohms. All are in parallel. One end of all the resistors connected at one point, other end connected at other point. Then these all are parallel. So in case of R parallel, what you can write? You can use this formula. 1 by R parallel AB is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Otherwise, identical resistors. Now, identical resistance means RAB is equal to R by N. How many are there? 3 are there. So R value is 15. So RAB is equal to 15 by 3. That is 5 ohms we get. Now see another application. Suppose you can take a resistance wire of resistance R is divided into n number of pieces. N number of identical pieces is divided like this. It divided into n number of pieces. Each piece they connect like this, parallel to each other like a bundle. They connect like this. Each wire is they connect like this parallel. All the wires are connected like this. Then what is the resistance of this combination? Actually for whole wire it is R. When you divide into n pieces, length decreases. Length decreases means resistance also decreases. Why? Because R is equal to rho L by A. So each part of wire area of cross section is not changing, only length changes. So L become 1 by n times. So resistance also 1 by n times. Suppose one of the piece if you take, what is the resistance? It is R by n. R by n. Now these all are connected again parallelly. In parallel combination, what is the resistance formula? In parallel combination, 1 by R parallel is equal to 1 by R1 plus 1 by R2 plus 1 by R3, so on, 1 by Rn. Of course, here identical, no? Identical, we have a direct formula, that is R parallel is equal to total resistance by N. What is the resistance of each part here? R by N. R by N by N. R by N by N. So get N square. Otherwise, you can substitute here value. What do you get? 1 by R by N. Why? Because each wire, what is the resistance? R by N. R by N you can send to numerator. Plus 1 by R by N plus N by R. Like that, how many N terms is there? So what you get? N into N by R we get. That is, we get R by N square we get. R by N square. This application only sometimes they will ask like this. A wire is there which is having resistance R. They fold at midpoint like this. They fold at this point. And between these 2 points A and B, what is the resistance now? So you know that this total resistance is R, means this part is R by 2 and this part also R by 2. 2 parts of wire. And those two are parallel. Parallel means what you get? Equal resistance is there. Here R by 2, here R by 2. So how many you are connected such resistance? Divide by that number you get. N means by N we get. So what is RAB here we get? That is R by 2 by 2. Because 2 are connected. So it means R by 4. Other case, suppose you can take the conducting wire of resistance R is made in the form of circle. What is the resistance of the total circular wire? That is R. Suppose if they want point A here, exactly opposite point B is there. Between A and B, what are the resistance? What is the resistance between A and B? You know this part of resistance is R by 2. Total is R. This part is R by 2 and this part also R by 2. Between A and B, this part and this part are parallel. So what you can write? RAB is equal to R by 2 by how many are there? 2 parts by 2. So you get R by 4 you get. R by 2 parallel means you get R by 4. Otherwise only 2 resistances are there. R parallel is equal to, we can use formula R1 R2 by R1 plus R2 we can use. Using that formula we can get this. Suppose here if you take point A here, resistance of the circular loop is R, point A is here, and if you take point B here, and this make angle, this make some angle here, that we take it as theta. What is the resistance between points A and B? For this, for total loop, what is the resistance R? Nothing but for 2 pi radians. What is the angle at the center? 2 pi radians. For 2 pi radians R means for only theta radians how much? That we can take it as this part, we can take it as R1, and for this part we can take it as that angle is 2 pi minus theta, and this wire resistance is R2 we can take. How we get R1? R1 nothing but total resistance R by total angle 2 pi into angle made by this part of the wire at the center is theta. Because theta increases, length of the wire increases. Length increases, resistance also increases. What you can write here? R is proportional to theta we can write. Similarly, what about R2? Resistance of the second part of wire, this part of the wire. Total resistance into how much angle that part made at the center, that is 2 pi minus theta. So you can write 2 pi minus theta by total angle 2 pi. We know R1 and R2 values, R1 and R2 values. These two are parallel between A and B. So what you can write parallel resistance. Suppose 1 by RAB is equal to parallel combination 1 by R1 plus 1 by R2 we can write. From that what you can write reciprocal of this. It is 2 pi by R theta plus 2 pi by and R into 2 pi minus take it LCM and finally take reciprocal. This we can write 1 by RAB is equal to LCM we can write that R theta into 2 pi minus theta in denominator and numerator 2 pi common and what you get 2 pi minus theta plus theta, so you get 2 pi. So from this take reciprocal RAB is equal to R into theta 2 pi minus theta by 2 pi and 2 pi 4 pi square we get. So you can take points A and B at any position. If you know angle between those two positions and making at the center how much angle they made, then we can calculate resistance between A and B. This part is R1, this part is R2. We are applying parallel combination of the resistance. Another case, suppose you can take 4 identical resistors are connected in the form of a square. Each of resistance R you can think A, B, C and D. Suppose if they ask about resistance between opposite corners A and C or B and D. So for that you see between A and C one resistor R is there connected to D. From there another resistor is connected to C. This is A, C, R and R. In other branch A to B one resistance is there and B to C another resistance is there. So R and R. Now these two are series and these two also series. Then what do you get from this? In right A, this is 2R which is connected to C, 2R series combination. This also 2R. Now 2R and 2R are parallel. So if two equal resistors connected in parallel, you get half of that. Or n equal resistors connected R by n. So only 2 now, by 2 we can take. Then what do you get? R AC is 2R by 2, R we get. Suppose in this case, if they ask about across AB, if they ask across AB, across A, we can take B. Between A and B, one direct resistance is there. Like this we can take. That value is R. And between AB, R plus R plus R, 3R in series. Like this we have. From this what you get? R plus R plus R, 3R we get. Between A and B, one resistance is 3R, other resistance is R. What do you get? RAB. This into this. If two resistors are in parallel, we can write short formula R1 R2 by R1 plus R2. This into this, 3R into R, that is 3R square by R1 plus R2, that is 4R. Nothing but it is 3R by 4 we get. Now let's say another case. The wire is folded like this, like English letter A. All the parts of wire is equal resistance, that you can take it as a small r, also R and this also. Suppose between these 2 points P and Q, what is the resistance? Between P and Q, what is the resistance? For this we can write equivalent circuit diagram. At point P, one resistor is there. This is the point P, one resistor. And that resistor connected with 2 resistors. The other resistor connected with one more resistance here and connected to the resistance here. So this resistance is R and this resistance also R. That resistance connected with one more resistance here. Both are joined here. These two combinedly they connect with another resistance R. And connected to Q. Now they want resistance between P and Q. So for that, first these two are series. So that is 2R we get. 2R and R are parallel. 2R, R and parallel means 2R into R by 2R plus R, 3R. So it is 2R by 3. This total value what you get? 2R by 3. This part is in series with these two. That is R plus R. So what you get here? 3R plus 3, 3 plus 3, 6. 8R by 3 we get. What you get resistance between PQ? That we can write it is 8R by 3 we can write. Another application we'll see now. Suppose you take a conductor which is having area of cross section A, length is L, resistivity R, specific resistance is rho. What is the resistance of the conductor? That is R is equal to rho L by A. Suppose if they give that resistivity changes according to distance. Suppose at a particular distance you can choose here which is X distance from the side A. Suppose of this end P and Q you can think. Between P and Q. And this is A is area of cross section. At a particular distance X and what is the resistivity means? Resistivity changes like this. That is you can take AX plus BX square. Resistivity of the conductor changes according to this. Now see another application, that is if you take a conductor which is having cross sectional area A, length L and resistivity rho. What is the resistance of the conductor? R is equal to rho L by A we can take. So this formula we can use when rho resistivity is constant. For a given material resistivity is constant. Suppose what happen? Without changing the dimensions, area is uniform, length also there, and but resistivity changes. Here one resistivity is there, here different resistivity like that. Resistivity changes according to a particular equation. Rho is equal to A plus Bx. Suppose the resistivity of this conductor at a particular distance x from the one end. Suppose this end you can take it as P and that end you can take it as Q. From P end, how resistivity changes, that they give equation like this. Now what is the resistance of this conductor between P and Q? For that we can't calculate at a time because resistivity continuously changing. That's why you can choose a particular portion here. A particular portion which is X resistance from one end and the length of this distance, this small portion is dx you can take. Now calculate what is the resistance of this small portion. That you can take it as dr. dr is equal to rho length dx by area cross section A. What is rho here? This changes according to this, that is A plus bx into dx by A we get. Now what is the resistance? Take integration of this. Resistance R is equal to integral. X value changes from where to where? From 0 to P to Q, from 0 to L length. So X value changes from 0 to L length. A plus bx into dx by A is there, that we can write outside. That area cross section is constant. Now what you get? Resistance R is equal to 1 by A outside. Integration of a constant A, B, AX we get for constant. For Bx what do you get? B outside. X square by 2 we get. Integration of X is X square by 2. Substitute upper limit and lower limit, and now we solve. R is equal to 1 by A. If you substitute upper limit, what do you get? AL plus BL square by 2. Lower limit means you get 0. So no need to take that. So what you can write? Here L by A you can take common, and 1 plus or A plus BL by 2. This is the resistance of the conductor. So if resistivity changes, how resistance changes, that we get relation like this. Of course they may change this formula. That formula we can substitute here, apply integration. So one of the application, suppose you can take a cylinder. So inner radius of the cylinder is smaller and its outer radius is capital R. Suppose if you take two terminals, one is inside and other is outside. What is the resistance between inside and outside of the cylinder? Between inner surface and outer surface. Of course from here to here, what is the distance difference? That is R capital R minus small r. That we know. Length we know. Where to where current flows, that we know. But what about area? First the current is going from inside to outside with an area which is having small cylinder. Small area is there. When it is going outside, what happens? Area keeps on increasing. So here area changes. So to calculate that variable area, you can assume at a particular distance here, x distance from the center. This is the axis of the cylinder you can think. And here you can assume a cylindrical motion. Which is having some thickness dx. First you calculate what is the resistance of this small portion at some particular position. Thickness you can take it as dx. And what is area? We know. Now radius is x distance. And what is resistance? General resistance formula R is equal to rho L by A. Here small sample of resistance we are taking. Rho is constant everywhere. It is made of same material. Length like what? Through what distance it travels. Suppose here to here x distance, and where to where current flows or current travels, that is dx distance. A small thickness you can assume. This thickness. A cylindrical and tube we are assuming inside, which is having thickness dx. So length is dx, it flows dx length. What is area? Area of the cylinder. This area we can take it as surface area of the cylinder if we know length of the cylinder L. what you get surface area of the cylinder, that is 2 pi r 2 pi l into x. You get curved portion of a curved surface area of the cylinder. Now apply integration to get total resistance. Total resistance is equal to rho by 2 pi l for given cylinder is constant, integral 1 by x dx. Limits are changing from where to where. In inner surface is r distance from center and outer surface is capital R distance from the center. So here this r is resistance, this r is radius. Okay, here capital R is equal to rho into rho by 2 pi l, and 1 by x integration is log x. Log x. Limits are changing from small r to capital R. Then what you can write, resistance R is equal to rho by 2 pi l. First substitute upper limit minus log lower limit. Log A minus log B we can write as log A by B. So resistance R is equal to rho by 2 pi l in denominator, and that we can write log capital R by small r. This is base E means. Now see another case. There is a hollow sphere which is having inner radius small r and outer radius capital R. Resistivity of the material is rho. Suppose what is the resistance between inner surface to outer surface, or if you connect some battery between inner surface and outer surface, how much current is flowing, like that they can ask question. And general formula for resistance R is equal to rho L by A. And but here area keeps on changing, that's why you can assume a particular position. At a particular position, x distance from the center, assume a hollow sphere of thickness dx thickness, you can assume. This thickness is dx. Now what is the resistance of only this shaded area or the sample what we assume, which is having thickness dx and distance from the center is x distance, that is radius of the sphere is, hollow sphere is x. Then resistance dr is equal to, we can write rho dx by area. Area nothing but here what you can write in place of area, surface area of the hollow sphere. Radius is x now, so you can write 4 pi x square rho dx by 4 pi x square. If you want total resistance, and radius changes from small r to capital R, or it is better to take A to B. A and capital R is B you can take. So now take integration rho by 4 pi integral 1 by x square dx. Limits are changing from A to B, inner surface to outer surface. So here 1 by x square integral x power n dx means you get x power n plus 1 by n plus 1 you get. Similarly x power minus 2 is there. If you bring it to numerator it becomes x power minus 2. X power minus 2 plus 1 by minus 2 plus 1. Then what you get? Minus 1 by x we get. So integration of 1 by x square is minus 1 by x. That we can write r is equal to rho by 4 pi. Here integration gone. 1 by x minus, limits are changing from A to B. First substitute upper limit, then lower limit. R is equal to rho by 4 pi. Then what do you get? 1 minus 1 by B minus 1 by b, minus in formula here minus 1 by a, so plus 1 by a you get. From this what you can write, make it LCM, that you get b minus a, so resistance from inner to outer surface of the sphere is rho into, here it is b minus a by 4 pi into AB or BA. Okay, right. Another application when resistors are connected in series and parallel combination. Suppose you can take a ladder of resistances connected like this. Like that, these are connected to infinite. Suppose for example you can take this is 2 ohms and this is 1 ohm, 2 1 2 1, so these values are repeated for each branch. 2 and 1 are repeated. Suppose between these 2 points in the points A and B, what is the resistance between these 2 points? If infinite ladder like this, resistors are arranged like this, repeated, 2 and 1 is repeated like this. Think that up to here resistance is unknown, that is X you can take. This total we can take resistance as X between A and B. For this, here if you add one more this sample in front of that, that means in front of this, if you add one more sample like this, if we join like this, here we are adding one more sample like this, then what is the resistance here? You can think A dash and B dash. Between these 2 points, what is the resistance means? Again you get X only. Why? Because on adding one of the sample or removing one of the sample, adding one of the sample, there is no change in the resistance because it is already having infinite samples, infinite ladder. So this resistance here also we get as X. These values 2 and 1. Now how to solve? These 2 are parallel. So 2 are parallel means what you can write? R1 R2 by R1 plus R2. X into 1 by X plus 1. This total is in series with this, that is 2. In series with 2. That total again is equal to X. Right? Equal to X. Make it LCM and cross multiply. What you get? X plus 2X plus 2 is equal to X square plus X. So 1X get cancelled. So what do you get finally? X square minus 2x minus 2 is equal to 0. It is a quadratic equation. So to calculate square roots, what is the formula? That is minus b plus or minus square root of b square minus 4ac by 2a. Like this we can calculate for that. What do you get in place of b? Minus 2 is there, so it is plus 2 plus 2 square 4 minus 4ac. So 4 into minus 2 is there, so it is 8 plus 8 by 2a 2. That what you get? 2 plus or minus root 12 by 2. Nothing but you can write 1 plus or minus root 12 we can write as 2 root 3. One of the value get 1 plus root 3, other we get 1 minus root 3. But 1 minus root 3 means you get less than 0. Means negative value we are getting. Resistance, negative value not possible. So what is answer? Resistance between the ends AB is equal to 1 plus root 3, that is 2.732 ohms we can write.
Like that, they can give here one more resistance. So apply same thing here up to here. You can take X and add one more ladder like this, which is the repeated one that you can add and apply parallel and series combination formula. You get a quadratic equation that is solved using square roots formula. X equal to formula. Now you see application based on combination of resistance. For example, now see application based on combination of resistors. Suppose in a lab we have only resistance we have, that is R. It can capable of carrying a current I. But we want to build a new resistance which is having resistance value R net and the current required to flow through that is I net. Example you can take resistance value, you can take it as 5 and the current you can take it as 2 amperes. And finally I need a resistance 50 ohms and the current flowing must be equal to here 10 amperes. I need current 10 amperes and resistance 50 ohms. Suppose if you use only one resistance, what happen? Its resistance is 5 and it can capable of carrying current only 2 amperes. First in this case you have to build a motor to get that net current. So how many this type of wires you have to connect in parallel to get this much current? So to increase the strength of the current through the wire, you should connect parallel wires, parallel combination you should use. How many you have to use? Like this, 5 you have to use, 5 resistors you have to connect in parallel. But because each can carry 2 amperes, like the 5 into 2, 10 amperes we get. So how many resistors you have to connect in parallel, that how we get means the required current I net by I. So how many you are getting? I net by I, that is 10 by 2, that is 5. 5 resistors you have to connect, each carries 2 amperes, like the total 10 amperes it can carry. Like this. Now what about the resistance of this combination? In parallel combination, each of resistance 5 and connected resistance also 5. Each of resistance 5, connected resistance 5. What is the resistance of this combination? That we can take as Rp. Rp is equal to R by P. That is 5 by 5, 1 ohm we get here. 1 ohm. So but what is the required resistance? 50 ohms required. But here we have only 1 ohm. Even if you connect more resistors in parallel, there is no use. Why? Because in connection of parallel resistance, parallel combination, resistance can't increase, it decreases. So to increase the resistance, we should use this type of sets, number you have to connect in series. So this type of set we are taking here, and one more set we are connecting like this. Like that, one more. Like that, we have to connect this type of sets until it gets 50 ohms. You know what is the resistance of each set? That is R parallel. So such sets how many required? So now the number of sets in series combination required is that is S is equal to their number of resistors in parallel. Here number of sets in series. This type of sets 5, 5, 5 like that. So how many sets required? That is R net by R parallel. Not R net by R. But because this total set has a resistance R parallel only. This type of resistance, this type of boxes, how many you have to connect? This type of sets, this many you have to connect. Nothing but that is equal to R net by R parallel, nothing but R by P. R by P. So from this we can write P nothing but I net by I, that is I net by I into R net by R we get. How many such sets required in series combination? This many. And total how many resistors are required? This many sets are there in series And for each set, how many resistors are there? P number of resistors are there. So total number of resistors here. Total number of resistors to build a resistance like this means that is here parallel into series. So N is equal to parallel, nothing but what you can write, I net by I. Series, what you can write, I net by I into R net by R. So I net by I, again repeated, R net by R we get. This many number of resistors are required to build this resistance.